a computation is done by the computer. So that is the main goal here. So let us understand first the word. What is a computation? So basically, in case of computation, will represent as we have a central processing unit, and it will interact with the memory, and we can perform any computation. If we consider a simple example of computation, the first thing which will came in our mind is the computer. And other simple thing, if you recall the history, then we can say the basic calculator, a calculator which is a simple calculator which does operations like addition, subtraction, multiplication, division. So how it actually works, it has some memory. We are entering the numbers, it will memorize that number, and it will perform the computation on it. So that is what the computation is. CPU, when it interacts with the memory, and we are able to do the computation. So it is a central processing unit which interacts with the memory, and we are getting the computation done. So that is how we can say that basically the computation works. Now, when we think about this computation, uh, other than this computation, uh, there are many other parameters which are very important for us. So if we consider the other parameters of this computation, then we can further expand this diagram into a memory having 5 major components: the input memory, output memory, the temporary memory, and the program memory. So basically, when you consider your microprocessor subject, microprocessor fundamental and programming, you might very well aware with this concept that you have in 8086 microprocessor, we have various segments like code segment, which is equivalent to a program memory where you will store the program. We have input memory and output memory. So in case of input memory, we are dealing with where you will store the data, that is known as a data segment, input memory, and output memory where you will get the output also. And also we have some extra memory to do the computation, which is known as a stack segment, right? So we have a temporary memory as the stack segment, we have program memory as the code segment, and we have memory that is main memory which we are using, that is known as a data segment, input memory and the output memory. So from the input memory, the input will be entered by the user, and then CPU through various registers like accumulator and other things, it will do the processing, right? So that is how the computation will be done through various mnemonics like add, subtract, and other operations, and the output will be stored into the output memory. If the program is complex, we may need some temporary memory to store the temporary results, and sometimes we are using for that a stack as a memory. So basically in computation, we have 4 different memories: input and output memory, temporary memory, and the program memory. So these are the various components of, we can say, a computation if we elaborate this diagram. Now further, if I expand this concept, then this theory of computation, or your subject theory of automata and formal language, what it focuses on 3 main parts: that is computability, complexity, and automata. So when we consider this computability, what can be computed? Can a computer solve any problem given enough time and this space? Can we do this thing? So that is the main part of computability. Can we use our computer to do everything? Normally, when you watch any Hollywood movies, you feel what a computer can do. We have a larger than life picture over there. Lot of devices are there. Lot of animation you can see, and you feel yes, computer can do almost all the things. But may not be the true. Can a computer do everything? No, there are many limitations of the computer, right? Even computer cannot detect a certain simple things, right? A recent example which I had, that